Hello and welcome. Thank you for joining us today to this new webinar from Circontech. My name is Will and with me is Marcelo, our AI expert and AWS architect, who will be our speaker today. In today's session, Marcelo will be showing us a practical example of multimodal agents in WhatsApp and how these type of solutions can be launched in AWS. Before we begin, let me remind you that you can contact us after this presentation and schedule one-on-one meetings with Marcelo and the tech team. We will be happy to answer any questions and support you in your initiatives. So without further ado, I'll hand it over to you, Marcelo, to begin the webinar. Thank you.
Thank you, Will, and welcome everyone. Today we will be focusing on the possibilities and practical applications of multimodal agents. We will be discussing a WhatsApp bot that can manage multiple ways of messaging. For this, there are multiple approaches that we can take. Lambda orchestration, Bedrock agents using something like LangChain, step functions. So which one to choose? Just to show a little bit how this can work, I built a hybrid system to understand when each approach makes sense. And by the end of this session, you will have a concrete idea of how you can apply this to your own context, and you will understand why certain architectural decisions matter. We have seen three generations of virtual assistants evolve. Generation 1 was those frustrating rule-based systems that we all remember and that some companies still use. Generation 2 brought NLP with intent classification, which was a little bit better but still quite rigid. And now we are in a Generation 3 with Gen AI. The fundamental change we are experiencing now is before we had to program every response path. Now we define the capabilities and let the agents, the AI agents, reason through problems. Instead of if X, then Y, now it is, here's what you can do. Figure it out. This paradigm shift changes everything about architecture, costs, and what's actually feasible. So what does multimodal mean? This means that the agent understands and reasons across different formats, not just accepting different file types. It's about truly understanding what is happening in each of the modalities. For instance, a customer sends a photo of a damaged product asking for warranty, saying, "Is this covered?" The agent then can use a model like Cloud Vision to identify the damage, then goes and checks the policies, chooses how to respond. And do I respond by text, all the instructions, or do I give a visual guide? In our implementation, we use different approaches for different tasks. Image analysis, and that we process directly with Lambda. We are going to see why. And image generation, and for this we will be using agents, and we will explain why later. And the same for other approaches that we'll be sharing on how this architecture can change. Everything you see here is something that you can implement right away. It exists. It is ready to be done and made into your product. We are using Cloud Sonnet. We're using 3.5. You can use 4. We are using Cloud Vision. For embeddeds, we are using Titan. We are using Stable Diffusion for creating images. You can use any of the other available models. And we are also taking advantage of specific services that AWS has and has had for a while, like AWS Transcribe and Amazon Poly. what's the flow here is a voice message arrives, then a webhook downloads it to S3 and triggers the transcription. The transcribe processes run in an async way that takes, I don't know, it can take up to a minute, and then fires a callback that routes the transcript to the agent. The agent processes and responds. If the user requested audio, then the service called Poly synthesizes the response before sending it. One thing that is critical here that we are going to see in a minute is this async pattern. Why we use that? Because we are using WhatsApp, and WhatsApp is expecting a quick response. So if we have a task like a transcription that takes longer, we need to still confirm to the system that, okay, we are alive and we are doing something. So WhatsApp interprets that there are no errors, then we are going to be uh, working soon with another response. We are going to see this in a minute and aid with the architecture diagram, so it is very clear. For architectures, as I mentioned, there are no universal correct architectures. Right now I'm going to be showing serverless because this is an accessible entry point where most of you can start right away. And this is perfect for variable traffic. If you are having more traffic, perhaps you have to go looking into more solutions like using containers, for instance. If you have like consistent high volume, or you need to use custom models that you have to package in some way. This will give you more control, and in scale, they can be cheaper. So how do you build this? There are different ways. There are decisions that you have to take. I built this demo several times and it worked fine, but I saw that we had to concede in some areas. So that's why I finally decided to show this hybrid architecture. For instance, if you have some deterministic operations, you can use everything orchestrated through the Lambda. If you have something like image analysis for that, there is something straightforward, you can do it using that. But if you have another action like image generation, for instance, the user will ask what he wants, like create sunset, but that is not detailed enough to give to the image creation model. So you need something in between to take what the user said and create that into a prompt that says exactly how to create that sunset, like a photorealistic sunset over mountains with the golden hour lighting, with vibrant clouds, with a resolution of 8K. For that, we use agents. So an agent will take what the user requested and makes this nice prompt and gives it to the model that is going to be creating this image. Um, okay, we are going to be looking at these specific details at the time of the demo. For memory, WhatsApp gives us not only memory of how to identify who am I talking to, who is the user. In this specific case, it's pretty easy because WhatsApp gives us the identity using the phone number. So this phone number can become the session ID. Of course, you can program this any way you want, but this is a nice and direct way of doing it. So you don't need login, you don't need cookies, you don't need tokens, and the session management is much easier. And for each phone number, you get an isolated conversation. And then the Bedrock agent can maintain a session state automatically. So the user A and user B have completely separate sessions and context, and there's no risk of mixing up information and getting to a user information from another. For another implementations like a web chatbot, this can get a little bit trickier where you need to manage session storage, token expiration, the cross-device sync, and you have a more complex setup to take care of. Talking about the types of memory, just very quickly mention that. We have a session memory. That is something that Bedrock Agents gives you for free and is very easy to use because it's already there. That can maintain the context by including the conversation history in each call. For instance, depending of the model, you have a 200K token context window for Claude 3.5. That could be like 50 to 100 messages. When you hit that limit, all the messages drop off. So this is perfect for the current conversation, but if a user returns tomorrow, that context is gone. So then you have to think, okay, how do I keep that context? Then you have persistent memory, which requires some additional infrastructure and a little bit more of coding. And for this, you can use DynamoDB, for instance, or S3, or you can use knowledge bases that Bedrock gives, but you have to see how to take that information and be storing it in those knowledge bases, how to sync it, and how to use it. For memory limitations that you have to be aware of, and you have to know that there are limits that can have impacts in the functionality and the cost. So you have to be aware how many tokens you are going to be managing, how many tokens an image consumes if you are going to read it or if you are going to make it and send it. So if you have image heavy conversations, the context window is going to be filled quicker. So you have to plan for that. And cost, it then is something that you have to be very aware of because it compounds, because each message includes the full history. And even though there are very clever ways of managing that history, at the times passes, you are sending more tokens, and that means more money. That's why you have to plan for your architecture taking this into account. There are also solutions that you can implement very easily, like session timeouts. After a certain time, just create a new session and restart that. You can summarize all conversations. You can get that information into a database and then getting the important parts only when you need them. So the recommendation is if you are just going to start, you don't need to worry about these optimizations from day one. Using just session memory, it's okay to start, and then you start adding these layers of optimization when users actually start hitting these limits. And as any development in premature optimization only adds complexity that is not giving you value. This is something that I just briefly mentioned about the persistence options that you have, how you store this information so you have it ready for the conversation as it keeps going. For architecture of what we are going to build, let me show you this. Okay. This is basically the entry point where we are using API gateway that is going to be communicated with a Lambda that is going to be identifying what type of messaging and the system is receiving. And in case this message has a file, it's going to see what to do with that file. If it is an image, it's going to store it in an S3, and if it is an audio, it's going to download it and also store it in an S3. So it has it ready for the next lambdas that are going to be processing this in the future. We have this orchestrator that is going to see, okay, now I have this message with this type of file that is media or not. What do I do with that? If it is a transcription, it calls another lambda that calls this service called transcribe. If it is text to speech, because it needs to generate this speech using this other service called Poly, calls this other lambda that generates this audio that gets stored in this bucket and then is sent through WhatsApp to the user with this with a function that we have here that is taking care of all the messages that are being sent. For some of the parts, like I mentioned, this creation of the image, we are going to be using Bedrock directly using agents for this tuning of the prompt and creating the image and then sending it back to the user through WhatsApp. Okay. Okay, in the live demonstration, I'm just going to show you very quickly how does it look like on WhatsApp. I have my WhatsApp web here. I'm going to just send the message. I'm going to be using my phone, but you can see it there. Okay, now I'm just going to type, hello, how are you? What's happening here? So I send a message from my phone through WhatsApp through an app API 8 point here. This is processed by this uh, lambda here. They're saying, okay, what am I receiving here is processed by this other lambda function that it says, okay, do I have to do something with this file? Do I have to generate an image? Do I have to create some text? Do I have to create some audio? Do I have to analyze anything? No, in this case, it's only text, so I can reply right away, calling from Lambda function and model that is going to create a message and send it through this other function back to WhatsApp. So here's the response that I have. Okay, he's doing well. Thank you for asking. Okay. What else can we do? We can send an audio saying, hi, do you know what a cat is? Okay, I just made a really silly question in audio. So, how is this app or this system going to interpret this? Again, we go here. What happens here is I send this audio through WhatsApp. It interprets as an audio file. This audio file has to be transcribed. So all these lambdas intervene. This lambda in particular calls this service Amazon Transcribe, creates a JSON with the text of the audio that I sent, stores it here. This is uh, sent here. This is an important thing. The transcription is not something that happens right away. And as I sent a 2-second audio, I could have sent a 10-minute audio. So that's going to take a while. That's why we need here two functions, one to start the transcription job and another one to understand that the transcription uh, ended. How do we do that? After the transcription ends here, this JSON file is going to be stored in this S3. So this is going to be triggering an event, and as soon as this file is put there, this other lambda function is going to be called, saying, okay, now we have the transcription ready. We are ready for it to be processed and to be sent back to the user. Okay, here I got the explanation of what a cat is as I requested, and then I can ask again, but I can ask it in text or in audio. Is like send me an audio with a description of what a dog is. Again, what's happening here is the message is sent, is processed here. This text is, okay, what do I need to do here? I need to create an audio. How do we create an audio? We call this function. This function calls Amazon Poly, creates the audio that is stored here and sent back for processing. Here we got it. Just let me see. I don't know if you will be able to listen to it or to hear it.
A domesticated mammal, often referred to as man's best friend. Dogs commonly bear.
Okay, so this is the audio with a very strong Spanish accent because the audio is configured to be in Spanish because that's how I had my demo, but you can have it set with any voice in any accent and any language that you choose. Important part is that here we got the information that we requested. And now we can ask for an image. Give me or create, draw a horse. Again, this is the case that I was mentioning at the beginning, where we are calling these agents here inside Bedrock, because I just said draw a horse, but this has to be converted into a more complicated or more complete prompt for the image creation language model. So I get back this image. In the same way, I can send a picture. See. I sent a picture of one of my dogs sleeping. Let's see what this says. I didn't ask for anything or requested anything in particular. What's happening behind the curtain here is this picture is stored here in the S3 and then it is processed, and directly we are not using agents here. We are analyzing the image and getting back some response. Again, the response is in Spanish, and that is looking at the small dog that is laying, enjoying the sun. So basically, we have tried here all the different combinations of how to send a text, voice, and image, how to receive in those same. As you can see, it is not the same me sending text or me sending audio or me sending an image than the application sending it back to me, because the things that happens behind the curtain are different. Okay, this has this has a wide range of application, this type of things that we are showing right now for specific and very narrow use cases in WhatsApp. But this can be connected to many other systems, and we can do many other things. For instance, for customer service, you can have any kind of interactions and you can have them 24/7. You can have 24/7 customer support, where the customers send photos of problems, they ask questions, and they request help for how to operate a device, anything. So the agent can handle these routine inquiries, they can escalate complex issues, and this will reduce wait times, they can uh, cut cost, of course, and scale automatically without adding more agents, more human agents. For document analysis, this is something that you can do. As you saw, we analyze some images. Some documents can also be analyzed. forms, receipts, invoices. The agent reads them, they extract the data, it can answer questions, and this can be useful for insurance claims, loan applications, expense reports. This can take days or weeks if processed by humans, and this way we can do it in minutes. For content creation, okay, creating social media posts, marketing materials, creating product mockups, just describe what you need and you can get this visual or this content almost instantly. This is not for replacing professional work, but can be useful for handling high volume and low stake content that would be too expensive to create otherwise. For voice assistants, as you see, you can process voice in or out because some users prefer audio or the use case calls for that. So if you have long instructions, tutorials, confirmations of work, this can be used as with audio and can work better. Users that are multitasking or they have accessibility needs or need multilingual support, where you have one text response that can become multiple language and voices automatically. And this is related to what we just saw, the universal accessibility. You have different users with different needs. Some prefer voice, some text, some can't read, some can't type. So the system can manage all of this if the user chooses how to communicate, and the system can adapt. This same architecture or with minimal tweaks can be used for different domains. For education, you can have virtual tutors, you have exercise feedback for fitness applications. In healthcare, appointment reminders, even the initial triage. For business, lead qualification, technical support. For creative work, content generation, writing assistance. You have a set of patterns that can transfer from one vertical to another. And you can play with that and customizing the instructions and how you integrate and which tools you integrate to. So for what we just saw in the demo, we have different patterns. You have to use your needs and your experience to tell you which one to implement for your specific case. But the lesson here is this hybrid architecture is a way of matching tools to problems. If you have something that is deterministic, like just answering a text or creating an image, you can use Lambda that's just called the language model or agent that's just call it directly. If you have something that needs like multiple steps or to take some kind of decision, and then you can use agents, and you can use even agents, a set of agents and the supervising agents that takes care of what's happening, what they are doing, and how to coordinate that work and put it together. If you're going to start, we are going to share a GitHub repo where you can play with it and start with it. Also, there's the documentation for Bedrock, how to use it. You see if you have access to the console, it's pretty easy to get started with. And for experimentation, the barrier is pretty low. You just need an AWS account. For this specific uh, project, just set up the WhatsApp Business API, and a couple of hours you can be running. The costs are going to be low, under $10, so the risk is minimal, and you can start learning how to do these things and start thinking of a specific use case where this can be useful. So an important thing for taking this to production is to take a systematic approach and to define one specific use case. and not something generic like customer service, but something like automate order status inquiries. Just be sure to be very specific so you can measure and you can see if you are going to be having an output that is valuable. And you have to define your metrics before starting to write code and before starting doing all this. So you will know if this is something that is going to be really helping your business or not and where to focus your efforts. The common mistake that we see is customers that try to build everything on day one. They want multiple use cases with every feature and full scale. And that gets very complex. This messes with the timelines and with the budget. So the successful pattern is to execute one case exceptionally well, to prove value, and then expand. It can sound boring, but it's very effective. Okay. I don't know, Will, do we have any questions from the audience?
Yes, Marce, the audience has been engaging in the chat, and we have
Great.
three questions. The first one is, how hard is it to deploy and maintain a solution like this?
Okay, but this one in particular is ready because we made it and there's a GitHub repo. So you can take that and in a couple of hours you can be ready. You just need the access to your AWS console, Bedrock access. For some models you have to request access to, but that's almost instant. Setting up the WhatsApp Business API also takes some minutes. And creating the scripts that handle the Lambda, the permissions and all that's taken care of. But if you're going to do it by yourself, it can take a little bit longer, perhaps a couple of days, if you know what you're doing. So the complexity is basically in two places. First, the configuration of the agents. When you have to create the agents, write the instructions, you have to define the action groups with OpenAPI. That's what, when the agents use an external tool, you have to configure what tool is and how that tool has to be interacted with. So you need to, there's this standard of how this API works and what each of the endpoints do and how to access it. Um, then the integration with your systems, you write these action groups that call your APIs, handle authentication, the errors and formatting. And this can be or will be custom for your context. For maintenance, it is mostly instruction tuning for edge cases that you will start discovering and your users are going to be start discovering. So there's a bunch of things that you can get ahead of, but there are some things that you're going to be discovering in practice. That's why setting up properly observability and evaluations is something that you need to be very worried of. For creating the code of the Lambda, okay, it's pretty stable once you do right. And then there's low overhead since serverless scales automatically, but you need to be monitoring cost, errors, and performance. So basically, yeah, it is easy if you know what you're doing. It's not hard to deploy it and to maintain, but you have to be very aware of these different things. Otherwise, it can turn into a headache.
Great, thank you. The other question is, how do you integrate with order management, CRMs, or internal systems?
Okay, the communication with these external systems is through APIs. As I mentioned, you have these things called action groups, uh, which you configure in your agent. So how it works is you have a Lambda, which is a piece of code in your account that's going to be called, and this Lambda calls your API, handles the authentication, and formats the response. There's this OpenAPI schema that defines the function, and you add it as an action group. For example, for order status, a lambda call this specific function, accepts an order ID, which is information that you have, calls the order management system using credentials, and returns the status, date, and some other information that the API normally returns. This schema defines how this function will respond with all this information that you gave. And so when a user asks a specific question, like where's the order 1, 2, 3, 4, 5, this agent is going to invoke this action, calling this API with all the proper information, getting a response, and translating that into a natural language response. So it's going to respond naturally, like, okay, the order has been shipped. The critical point here is you have to take care of all the permissions throughout all this. So this is something that you have to configure, that you have proper access to the tools, and these can be called so you can get the reply.
Excellent. And one last question is, what happens with a solution like this when the traffic grows?
Okay, so if you start with something like the solution that we showed here, this is completely serverless. This scales automatically. So the cost and context management are going to be having problem before you have any problems with the infrastructure. What I mean by this is that you have to be very aware of what's happening with the cost, how many tokens you're processing, and any other external tools that you're calling that may have a cost. And the context management is something that we mentioned at the beginning. All this information that we have been sending back and forth to the agent, that is accumulating and that we are storing somewhere as a memory, but we need to send to the agent or to the model so it knows what it's talking about. If you have traffic that grows a lot, or you have an usage that works a lot, it's going to be a problem managing that first than any problems that you are going to be having with the infrastructure growing, because this is growing automatically and auto-scaling anyway. So you need to be very aware of the provision concurrency if you have to set that up, and monitoring, and if you are managing databases for persistence, all that you have to be you have to keep your eye on that, and but you shouldn't have any problem with the infrastructure per se if you set it up in a form that auto scales, just all the things around it.
Perfect. Thank you, Marce. So that will be all of the questions from the audience. Thank you.
Okay, great. So, well, again, thank you for time today. These were excellent questions. Show that you are thinking about how to adapt this to your own context. As I mentioned, you have the repo there. You clone it, deploy it, break it, fix it, adapt it. You can see more information on our website, or you can contact us directly. Here's our contact information. So if you build something with this, please reach out and tell us what worked, what didn't, what did you change. You can reach us at our email shown there and the links that William shared previously. Okay. Have a great afternoon. Thank you.
Thank you all. Bye bye.